Hey everyone, and welcome to my very first podcast episode. I'm Dison, and today we are talking about something that comes straight from sci-fi movies: maglev transportation. You might have seen maglev trains from sci-fi movies such as Tomorrowland 2015 and Big Hero 6 2014, which are fast, silent, and floating above the rails. And think that these technologies don't exist in the real world. However, these trains do exist and are operating in Japan and China. In this episode, let's explore and break how maglev technology works, how they levitate, their speed, the challenges, and the future of this advanced technology. So let's buckle up or levitate and get into it. What is maglev? Did you know that maglev stands for magnetic levitation? Unlike standard trains that use wheels which are rolling on the rails, these trains use magnetic force to glide or float a few centimeters above the guideway. And because there are no wheels in contact with the rails, there will be no rolling friction, which makes them smooth and a quieter ride. It's almost satisfying to imagine a high-speed train going hundreds of kilometers per hour. And the best part of maglev? They experience less mechanical energy loss, again due to less rolling friction. A good example is Japan's superconducting maglev. So, how does maglev train work? There are two suspension systems that work here. The first one is the electromagnetic suspension, also known as EMS, which uses electromagnets to attract the train upwards to the guideway, while a sensor and control system constantly adjusts the magnetic force to maintain a tiny air gap which is about 10 millimeters. This system is found and used in Germany's Transrapid design and in Shanghai Airport's maglev. The second is electrodynamic suspension, also known as EDS, which is used by Japan's superconducting maglev. In this system, the train has powerful magnets. When the train moves, the magnet induces currents in coils in the track. This creates a force that lifts the train with a gap of 100 to 150 millimeters. The train, once it starts moving forward, will be stable. However, the push does not come from these two suspensions or an engine, but from a linear motor in the guideway. You can imagine this motor as an unrolled electric motor. By switching the polarity of coils constantly, it will create a magnetic wave that pulls the train. Well, there are big benefits for using maglev technology. One of the main ones are its high speed and efficiency. According to JR Central, Japan's superconducting maglev hits 603 km per hour, and Shanghai Airport maglev runs up to 430 km per hour. And it's not just about speed. 2021 studies comparing maglev and traditional trains have found that maglev can use around 20 to 30% less energy than the normal trains because of its reduced mechanical loss. A third benefit that many passengers will like is the comfort, since the train doesn't undergo any vibration or noises from track. And finally, the last advantage that is liked by the public and environmentalists is that it is more environmental benefit than the traditional train, since it doesn't emit or release harmful gas to the environment like CO2 and NO2. So, now you might be wondering, if it's so fast and efficient, why are these trains not seen everywhere? Well, that's because there are some set of challenges as well. One of the primary challenges that engineers face is the need for rare materials to build different parts. These materials cannot be found easily, And there should be a complete set of new tracks for these trains as they cannot glide on the existing rail lines. Because of these challenges, making the maglev train can be expensive and quite a complex project. In some cases, there can be aerodynamic noise, which is the sound of air getting cut, can be a main issue. So, engineers will have to build tunnels or barriers to manage this noise, further increasing the cost. So, where are maglevs used today? As said before, which is one of the famous maglev is the Shanghai maglev, which connects Pudong Airport to the city. China too have several operative maglevs like the Changsha Maglev Express, and Beijing is one. And in Japan, there is the Kushino Chin project, which is under construction and is going to be from Tokyo to Nagoya. And finally, Osaka. But the project is facing delays and has been pushed back to 2027 unfortunately. When looking at the future of maglev trains, they could have a huge impact. Countries such as South Korea and Germany are researching and finding interest in freight maglev trains too. The researchers are trying to reduce the construction costs, which will further improve the efficiency. If the answer to this problem is found, maglevs can be used to have travel to different major cities. So, this is the fascinating world of maglev trains. The trains that glide on the tracks, the trains that is very fast and quiet, and the trains that is more comfortable than other trains. What we thought as a fiction vehicle is now a working technology that carries passengers in some countries in the world. We explored how maglev trains work. There are two suspension systems which lets the train float above the guideway with the linear motors that are pulling them forward. We see the benefits of maglev such as the record braking speed, the smoother ride and more. But we also looked at the big challenges from the high cost to the rare materials needed and the aerodynamic noise which can increase the cost more. The future of maglev is still in the process. If researchers find a way to reduce the cost, maglev trains could transform and change the way we travel to major cities. So, if the next movie you watch and you find a floating train, remember they are not fiction at all. Thank you for joining me in this ride through the world of maglev trains, and I'll see you in the future of transport.